Hello everyone. In this video, we will look into echelon form and how that echelon form can be used to find the rank of a matrix. So first we need to know what an echelon form is. So echelon form of a matrix is of this type or of this type. What is the meaning of that? The leading zero. So here you observe that this row is starting with zeros. So these are called leading zeros. So leading zeros should go on decreasing as we move across the matrix from below to top. Means we can say the number of leading zeros, for example here 1 0, here 2 zeros, if it goes on further, then number of zeros should go on increasing as we move down along the matrix row wise. So therefore this is in echelon form. This is also in echelon form because number of zero, there is no zeros are there, here we have 1 0. However, this is not in echelon form because the leading zero, here we have a leading zero, but here no such leading zero is there. It will be in echelon form if it is something like 0 to 1 and this is 0 0 5 or something. In that case it will be in echelon form. Means number of zeros should go on increasing as we move down the matrix. So that is called echelon form. Now why is this echelon form used? One more thing here, echelon form can be considered as also a staircase. Why is it called staircase? Because if you observe carefully, if you remove these zeros, it looks like a staircase, it is moving upward. So therefore it can be considered as a staircase. Okay, so why this echelon form is used? There are many uses of echelon form. One major use of that is to find the rank of a matrix. Now how can we find the rank of a matrix depending upon echelon form? It is very simple. Whenever a matrix is given, we have to convert that matrix first to echelon form. Once we find it in the form of an echelon form, the number of non-zero rows, so rank is nothing but the total number of non-zero rows. The total number of non-zero rows is the rank of the given matrix. For example, in this matrix, there are how many rows are there? There are 3 rows and all of them are non-zero. So non-zero because non-zero elements are there, therefore it is non-zero. So its rank is 3. If we consider this matrix, its rank will be 2 because there are 2 non-zero rows. Similarly, for example, there is another matrix, say 4 1 5 0 1 2, say 0 0 0. So in that case, the number of non-zero rows are 2. Although there are 3 rows, the last row is containing zeros. All zeros are there. So there are 2 non-zero rows. Therefore, its rank will be equal to 2. So the total number of non-zero rows is called rank. So based on this, we will now look into how can we convert any given matrix into echelon form. We have to first know how to convert, therefore we have to know how to convert a given matrix into its corresponding echelon form. So let's work on an example how we can do so. Now let's take an example. How can we find the rank of a given matrix? For example, we are given a matrix 2 by 3. There are 2 rows, 3 columns. So now how can we find the rank of this? So while finding the rank, we have to remember that since we are using echelon form, so we have to bring zeros in the last row first. We have to bring zeros in the last row first. So how can we do that? So first step is we have to consider the first element of the matrix as the pivot element and try to make it pivot element and try to make it 1. So that is the first way. So what we are doing here, so instead of 2, what row operations can we apply? So these are called row operations. So what row operations can we apply to make this 1? So what we are doing here, so if we divide this by 2, we will get 1. So what we are doing is R1, we are dividing the row 1, R1 means row 1, all the elements of row 1 by 1 by 2. So if we divide 2 by half, that means half into 2 is 1, 4 into half is 2, means 4 by 2 it is 2, minus 2 by 2 is minus 1. So that is about the first row. So we have obtained these values. So these values are obtained by using this row operation. Now what we have to do, since we have to convert it into echelon form, therefore we have to make the second row elements 0 as far as possible. So how can we make it 0? So one thing we can do is that this is the matrix that we have obtained after using this row operation. Now since it is 1, if we multiply this row by 4 and subtract it from this, means if we multiply row 1 by 4, if we multiply the elements of row 1 by 4, what will we get? 4 to the 8 minus 4, and then subtract it from these elements. So it will be 4 minus 4 into 1. So it is 0. So next is 5 in minus 4 into 2. 4 to the 8. 5 minus 8 is minus 3. So that means we are subtracting, we are multiplying 4 with this and subtracting with them. So minus 3 minus 4 into minus 1. So it is 1. So now it is in echelon form because leading zeros are there. And since there are 2 rows, it is the leading 0 is 1 only. So from this we can see that since there are 2 non-zero rows, therefore the rank is 2. So after converting into echelon form, we have to see how many non-zero rows are there. On that basis, we can say the rank. So since 2 non-zero rows are there, so rank is 2. So that is the way of finding the rank. It is a very simple matrix. We have seen how it can be done. Just I am repeating these steps once again. So we have to check whether it is in echelon form or not. If it had been in echelon form, it would have directly written the rank. Since it is not in echelon form, so we have to convert it into echelon form. So here we are converting it into echelon form by using some row operations. Many such row operations can be there, but the general idea is that the first element is considered as the pivot element and we try to make that element 1. And then we can use subtraction, addition, multiplication or any operation so that the leading zeros of the rows below can be made 0. We can get leading zeros in the rows below. So that is the way of finding rank. Thank you. In the next video, we will see another such example where we can find the rank of another matrix.